Good evening. Thanks for the invitation and the very interesting talks. I mean, it's a very humble talk after the two great presentation before. So I'm going to talk about new ecosystem for robotic surgery in MMI. I'm a software engineering director. And this talk is a continuation of what the PRND Massimo Simi has presented before. Okay. So essentially, we start back to the Simani surgical system. That is a system for microsurgery in which we are improving what the surgeon can do in connection with the surgical microscope. And as presented before, the key element is the teleoperation paradigm, similar but other teleoperator surgical robot, with the difference that we are working in open surgery and where the primary target is an anastomosis. And our system is meant to do, because it's a microscale, we are focusing on motion scaling and tremor reduction for improving the surgical outcome and giving the opportunity to surgeon to more precise and finer anastomosis. So we are supported by the activity of several surgeons that are using different cases in Europe and States, in Asia. And they're publishing on our robot, trying to understand which are all the benefits and demonstrating that. So here on the left, you can see the point about the use of the flying master that was introduced in the previous talk. On the right, there's a work by Vessel 2023 in which are discussing the advantage of the economics of our system. So this gives, well, what I wanted to give is some glimpse of which are the opportunities for the data that can come out, in this case from the OR, because improving the ergonomics of the surgeon is something that gives better outcome and less stress for the surgeon. The difference here is due to the fact that the surgeon is in a better and a more comfortable position with using the Simani robotic platform. So the key activity in which we are very proud of is the use of Simani for the anastomosis of lymphatic ducts. As we mentioned before, microsurgery addresses different type of vessels, lymphatics, ducts, and nerves. So this is a case of a 0.5 millimeter vessel with a very small suture and scaling factor. And the core of this activity is the suturing gesture. And this paper discusses the comparison, as many others, between manual surgery in the top right with robotic surgery, and going to look into the aspect of what is the final outcome of the anastomosis itself. So what is interesting is how the Simani layouts in the operating room, with the opportunity to understand which are the elements and the simplicity, but also understanding which is the role of the different elements on the surgery. So in this case, we are highlighting from this paper the primary surgeon that sits at the console, looking at the 3D screen with glasses. There's a vision system that is a digital microscope, in particular is an exoscope, and an assistant surgeon that does some activities manually while the primary surgeon controls the robotic system. And this paper was discussing the integration between the two elements. Because the Simani can work with the optical microscope and digital microscope, so there's a lot of discussion in the surgeon which are the different advantages and needs for the digital microscopes. This is a case in which both Da Vinci and Simani have been using the same case in University of Brussels, in Hospital Brussels. It was a lymphatic node transplant. Essentially, the Da Vinci has been used for getting to the donor site, accessing the lymphatic node, and there was transplanted another location under the armpit with the Simani, where there was done the lymphatic anastomosis in the context of lymphoderma. That is a very important side effect of several surgeries like breast cancer. So one aspect which we're very happy to help the patient is the area of the lymphatic surgery for recovering from lymphoderma. And this is an interesting use of two robots that are used in two phases of the surgery by different teams, clearly, because there is an handover between one team to the other, because the second part is done by the microsurgeon. One interesting point we discuss is that which are the vision systems of Simani. We go from optical microscope digital microscope, and even there is opportunity to use some cases robotic scopes. That's a robotic scope is the BHS system that uses an edge-mounted display that controls the robotic arm, and the surgeons can take advantage of any of the three depending their which one more comfortable. And this is this paper that discussing the pro and cons of different solutions, which are the different elements that impact the use in the surgical procedure. So the question that brings to this talk and this conference is that there's a little bit of discussion about data sources, vision and kinematics, ontology and task modeling, which understand which are the models, task and gesture, and how we want to close the loop with the surgeon before, for the preoperative phase, during the intraoperative, and after the surgery. And we would like to address all of them in the long term, taking advantage of the similarities with what occurs in the rest of the robotic surgery, although there are some differences in their microsurgical context. And we're tackling this by creating an ecosystem because as you see in the initial phase, we're showing that microscope was improving what the surgeon can see money what can do, and what we're improving more so what can see and do and think, actually, because we provide a workstation that is integrating this information, getting data from the Simani and the microscope, and providing feedback to the surgeon itself, and also integrated with information from the kinematics of the Simani. So we are doing some internal research in this area. So the results clearly are in industry and research are doing a lot great work. So we are trying to translate what's the best from research into our domain. This characterized by different context of terminology, specificity of our instruments. There is not much data on this in this domain. It's the main challenge. So there's not much transfer. So we are constructing our ontology for expressing our domain. So this is kind of example of an annotation that we are building over the scene, and there is also opportunities for doing, that's opportunity for doing tracking. Oh, here it not comes out. Good, and tracking also tracking of the kinematics. Yeah, it works. So we are doing a segmentation of instruments, something that in the very common in the history, but we're constructing our knowledge on the topic for integration. So the other point that we're in collaboration with the Politecnico di Milano, we are doing the research in the domain. In this case, was a recent paper published on a journal of computer-aided radiology and surgery on combining segment detection with a custom detection mechanism with some information about where things are, where the things move, and a mechanism. So there was a detection model for real-time analysis visual information, plus a data association for getting correctly where the instruments are going. So the paper presented some interesting results that are promising for understanding where the instruments are going in combination with our specific knowledge of that. And with also interesting having this solution efficient in terms of speed and accuracy. That's a starting point for integration in functionalities. So my conclusion are that we are sharing a lot of information with elements in common with the minimally invasive surgery, in particular laparoscopy, about the different aspects. There's an Ai2m because they are using digital microscope, different lighting condition, very big issues of depth of field because of the type of optics. So we think there is a lot of opportunity for assistance and information for the surgeon. We will continue on this research area. Thank you very much.